Good afternoon, everyone. I'm Alex Rosen with the Forest Service, the Pacific Northwest region in Portland. Now that we've heard about delayed mortality, up next are some flash talks on early-seral forests. So we'll have 3 different flash talks, followed by a group question and answer at the end, like we just saw. So first up is Madison Laughlin from the University of Washington.
Awesome. Hi, my name is Madison, and I'm excited to share with you today some of the highlights of my master's research, looking at the patterns and drivers of conifer regeneration following stand replacing wildfire. I might breeze through some of this context, it's kind of been covered, but obviously wildfires in the Western Cascades have received a lot of attention recently. The 2020 Labor Day fires are a sobering reminder that large wildfires do happen. Yeah, thanks. Large wildfires do happen in this system, and that we need to learn more about these fires so that we can effectively manage them, especially with the uncertainties of a changing climate. For this talk, I'll be focusing on the regions of Western Cascadia that are characterized by infrequent, large, and stand-replacing wildfires. And the fact that these forests burn at a relatively infrequent fire return interval presents some unique challenges to understanding fire in the system. And this is kind of highlighted by this map here, which is showing wildfire activity over the last 30 years. And you can see in the East Cascades, there's been quite a bit of wildfire activity. In the Western Cascades, there's really only been a handful of fires, and a lot of that has been over the last 10 years or so. And this recent wildfire presents a really unique opportunity to get on the ground right after fire and better understand some of the immediate post-fire recovery dynamics that are really hard to get at solely relying on retrospective methods. So for this talk, I'm focusing on tree regeneration, which is a critical mechanism of forest resilience. And as we all are aware, our Pacific Northwest forests have immense ecological, economic, and cultural value. So really important to understand how these forests are coming back and what factors may be driving some of the patterns we're seeing. And successful tree regeneration, specifically in stand replacing burn patches, relies on availability of a seed source, dispersal of that seed source into the stand replacing burn patch, and then conditions conducive to seedling survival. So we asked, how is post-fire conifer regeneration across Western Cascadia affected by pre-fire stand age, burn patch size, and topoclimatic conditions? For this talk, I'll be focusing on pre-fire stand age and burn patch size, but I love to talk about this, so if you see me outside this talk, I'd love to expand more on some of our other findings. Okay, so to go about answering this question, as Brian alluded to earlier, we've established 165 long-term monitoring plots across 8 notable wildfires that have burned in the last 5 to 7 years. And our goal we aim to sample these fires 3 to 5 years post-fire. So for this talk, I'm just using a subset of the data of these 4 red wildfires on the map on the right. And all of the plots I've included in this analysis are within stand replacing burn patches. We stratified plot locations by forest zone, so lower elevation warm forest zone and higher elevation cold forest zone, and by pre-fire stand age and structure. So we've got our young, mid-seral, and late-seral plots. And for the rest of this talk, when I refer to seedling abundance, I'm talking about regeneration rates, so the total number of seedlings per hectare per year. We used a generalized linear modeling framework to model seedling abundance as a function of pre-fire stand age, burn patch size, and topoclimatic conditions. Okay, let's get to the fun stuff. First, I'm going to focus on the findings related to pre-fire stand structure. But first, I want to set up some of the expectations we had going into these analyses. Under traditional narratives, we normally associate this early-seral conditions right after fire with shade-intolerant species. So this includes Douglas fir, noble fir, species that thrive in that high light environment. And then our shade-tolerant species like western hemlock and Pacific silver fir are typically associated with later succession and becoming co-dominant in the overstory in late-seral forests. Okay, this figure on the left is showing pre-fire stand age on the x-axis and our modeled seedling abundance on the y. And so our first big takeaway is we found that as pre-fire stand age increases, so does overall regeneration abundance. And this suggests that maybe there is increased seed supply into stands that were late-seral at the time of fire. And one potential explanation for that could be that given our plot, the star on the image, given that our plot was late-seral at the time of fire, potentially that nearest live seed source is also late-seral. Research has shown that late-seral forests produce a higher volume of seed and typically have longer dispersal distances. So this is one potential explanation. Another explanation is that late-seral forests probably have the highest probability of individual trees surviving that fire, and either outright surviving or surviving long enough to be able to put out a viable seed source on site. So kind of connects to some of the conversations around delayed mortality we were just hearing. But further research is needed to get at those underlying mechanisms of increased seed availability in stands that were late-seral at the time of fire. So not only did we find that regeneration abundance increased with pre-fire stand age, but so did conifer species diversity. So this is a similar figure, but on the y-axis, we've got Shannon Diversity Index of our conifer species. And some photos of our most abundant conifers, which included Douglas fir, noble fir, western hemlock. Before I go into this graph, I want to set it up. So on the y-axis, we've got our conifer species, and they're arranged by relative shade tolerance. So Douglas fir, noble fir, shade-intolerant species are at the top, and our more shade-tolerant western hemlock species are at the bottom. And it's on the x-axis, we've got percent of plot species are present, and they're separated by pre-fire stand age. So in our young plots, so these are plots that were young at the time of fire, we saw noble fir and Douglas fir consistent with what we would expect to find in an early-seral forest. But as we increased in pre-fire stand age, we saw a greater diversity of conifer species. And interestingly, not only did we see our shade-intolerant species, but we also saw quite a bit of co-establishment of shade-tolerant species as well. And to put that in perspective, western hemlock was nearly as abundant as Douglas fir across our warm forest zone plots. And this is consistent with some retrospective studies that have suggested co-establishment occurs on the west side. It was pretty common across our plots, and may suggest this pathway is a little bit more common than previously thought. And it has some pretty interesting implications for future forest successional trajectories. Because you would imagine in a co-established stand, you'd have more heterogeneity in species, size, and structure of forests. I'm going to speed through the rest of these results because I'm running out of time. But unsurprisingly, with respect to burn patch size, we found less regeneration abundance as you got farther away from a seed source, but we still had pretty robust regeneration up to about 400 meters. And this suggests that the interior of stand replacing burn patches are areas that are going to be slower to regenerate with trees. But this could provide a really unique opportunity to manage for disturbance-created complex early-seral. This condition is one of the most scarce on the landscape in western Cascadia, even more scarce than our late-seral forests. And Liliana will talk more about some of the coolness of this habitat. Okay, key takeaways. First, forests appear to be regenerating fairly well after stand replacing fire in the western Cascades. Late-seral conditions may foster resilience to severe fire through increased seed abundance and diversity. And finally, the interior of those large standard placing patches are likely to be areas slower to regenerate with trees. And yeah, again, these findings highlight the importance of late seral conditions and maybe suggest an opportunity to manage for complex early seral. Thank you for your time.